Hey, this is Mr. Barr, and I'm excited because this is the first video that I've made for this school year. And I'm going to go over what is the Math 8 goal number 1, real numbers practice test. And the learning goal is I can work with the entire real number system. All right, let's zoom into the first one here. So, what two integers is the following number between? Do not use a calculator. So I have the square root of 70. I don't know the square root of 70, and I can't use a calculator. So what are some square roots that I do know? Well, I know the square root of 64 is 8, and I know the square root of 81 is 9. So the square root of 70 is somewhere in between 8 and 9. So what I do is I find square roots that I do know before and after the number that I've been given. Okay, let's fill in the missing parts of this table. Let's see if I can. There we go. So 0.1, repeating, that's the same thing as 1/9. And if I'm going to be right back. I'm going to get a calculator. I know it says don't use a calculator, but let's just confirm it. Right? So if I put 1/9 into this thing, 1 divided by 9, 0.111 repeating. So I know that if I have just a single repeating digit, I just put it over 9. So this is going to be 4/9, 7/9. So following that pattern, if 1/9 is 0.1, 4/9 is 0.4, 7/9 is 0.7, 9/9 would be 0.9 repeating, or 1. And that is going to show up on your assessment. This idea that 9/9 is 0.9 repeating, even though it's a 1, and 0.9 is a 1. They're all the same. 0.9 is 1, which is 9/9. Okay, can the following number be turned in? Let's see. Can the following number be turned into a fraction? So I have 0.34189563 ... The ... means that it goes on forever without repeating. Well, I know that no, it can't be turned into a fraction. No, it's irrational. It goes on forever without repeating. If it goes on forever without repeating, I cannot turn it into a decimal. It's irrational. Irrationals cannot be decimals. Since the square root of 16 is 4 and the square root of 25 is 5, what would be a good approximation for the square root of 20? You may not use a calculator. Well, 20 is halfway, pretty much halfway between 16 and 25. It's pretty close. So let's say that the square root is about halfway between 4 and 5. So approximately 4.5, since 20 is about halfway between 16 and 25. Now I'm going to use a calculator to check it. See how close I got. What do we say? Square root of 20? 4.47, I think 4.5 was a pretty good estimation. The instructions for the next one are to classify these numbers based off of the best number set. So a non-repeating, non-terminating decimal, that's a good example of an irrational number. A fraction, that's rational. -10, that's an integer. A repeating decimal, that can be a rational. A terminating decimal is also a rational. So can you identify different types of numbers? Is the following number rational? How do you know it's rational? Okay, look at that. Oh yeah, that guy's totally rational. How do I know? It's a repeating decimal. Yes, rational. It's a repeating decimal. Repeating decimals are rational. Write the following as fractions. Well, I know that 0.3 repeating is 1/3, 0.7 repeating is 7/9, 0.9 repeating is 9/9, also 1. Let's see, is the following number rational? The following number is, the following number is irrational. What makes it irrational? Explain your reasoning. The number is pi. Well, pi, what makes it irrational? It goes on forever without repeating. Pi goes on forever without repeating. It is an irrational number. Next one. Megan made the conjecture below. Let's see, what does Megan think? Megan says, if a rational number is an integer less than 100, then the square root of the rational number is rational. For example, the square root of 16 is rational, and the square root of 81 is rational. She thinks anything less than 100, when you take the square root of it, is going to be rational. And she supports that because, well, look, 16 is less than 100, and it's rational. And 81 is less than 100, and the square root of that is 9, which is also rational. Well, she's wrong, because look, I chose two numbers less than 100. 2 and 3 are both less than 100, and both of these are irrational. I cannot take the square root of 2. Well, it's not a perfect square. So when I take the square root of it, I get a number that goes on forever without repeating, which is irrational. And same thing with 3. Okay, hey, thank you for watching. My first video of the year. I get to make 3 more today. Thanks. Bye.